Hi, in this video I'm going to talk about anomaly detection. Anomaly detection is a machine learning model which could help us to classify an abnormal situation. That is, a behavior that is unusual and lie outside the normal boundaries. So here I'm going to use a Raspberry Pi to simulate a situation where a machine component is behaving unusually. And I'm going to use this model and apply it to the Raspberry Pi so that during this abnormal situation we get informed. So let's get started. I'm going to walk through the code for building this machine learning model. In order to build the anomaly detection model, I need to generate features to feed into the model. And the features that I will generate are temperature and light. So these are generated randomly, forming a normal distribution. So let me execute these code. And to get a picture of what they look like, is best to view it in a histogram. As you can see here, it ranges between 18 to 27, and this is the normal range with a mean value of 23 here. And if I do the same for light, same principle, light, it ranges between 0 to about 0.5, and it has a mean lying around 0.25. And I'm going to combine light and temperature together using a multivariate Gaussian, and you will get the intuition of how this is formed later. So remember, these are randomly generated, so I will use a Gaussian to estimate what the parameters are. So mu and sigma is the mean and the variance. And in order to predict the probability, I will use a multivariate Gaussian function where I feed in the data and the mu and sigma that I generated earlier and feed it into here. Epsilon is also a very important parameter. What this is effectively the threshold where the probability must fall below in order to classify a data point as an anomaly. So here, temperature is plotted against light, and where my cursor is right at the center. This is where the mean of the temperature and the light intensity lies. And the further you go away from the mean, the lower the probability would be. As you can see, these two red points are when the points lie very far away from the normal distribution, and hence we detect them as anomaly. For the generated sigma, mu, and epsilon, I will save them into a NumPy file and git push them out to the Bitbucket, and when we log into the Raspberry server, we will pull these back again. So let's log into the Raspberry Pi. Okay, and let's git pull again. Before I execute this code, I should probably turn on the recording so you know what's going on. So I've SSH'd into this Raspberry Pi, And let's check that it's working fine. So just for sanity check, so this is a script where it will light up and buzz once. Okay, cool. So both red light and blue lights came on, and the buzzer sound is very apparent. So let's check also the temperature. So the temperature is giving me two readings every time it reads. So one reading is in Celsius, the other is in Fahrenheit. If I hold this temperature sensor, my body heat transfer will go into the sensor, and it should increase what the temperature is detected, and it is. It went from 17 degrees, which is about room temperature here, to now increasing towards 24 and towards 25 as well. Good. Meaning that the temperature sensor is also working normally. Next, let's check our light detector resistor. The light intensity in arbitrary units is about 0.2 and is fluctuating a lot because my shadow is blocking it. So if I even hover over it, it will block out the lights from the room. So it becomes 0. Now goes back to normal. The other thing that I want to check is if I shine light onto it, immediately you can see it jumps from 0.2 to 0.87 and then to 0.74. Okay, so that proves to me that the light detection resistor is also working. Good. Right, so the scripts that I've built is called Anomaly Detection .py. Okay, a quick look in this code. So the function I have is multivariate Gaussian function, which you saw earlier. So what this will output is a probability for every time I feed in the reading. And the reading is my temperature and my light reading from the sensors. And here I've activated the GPIO for the lights and the buzzer, and I set up the configuration for it for the temperature sensor and also for the LDR sensor, the light detector resistor sensor. So the function read temperature raw. Yep, this is just getting the temperature reading from the file that gets automatically logged. So I'm going to run a while loop. So the while loop is telling us we'll take the temperature reading, we take the light intensity reading, and we will at every reading made, we will calculate the probability. This probability is calculated using the multivariate Gaussian function. And you can see our input is the temperature, the light intensity, and mu and sigma is what we have brought forward from the previous notebook. So I've created a list. The list is called recordings, so it captures all the temperature, the light intensity, and finally the probability. So here I'm basically just asking the Raspberry Pi when it executes this Python, and if the probability calculated is smaller than epsilon, then immediately give me a red light, and I want to hear a buzz sound. Otherwise, you can just continue as normal and just show blue light to indicate that is operating normally. And then I will save my full recording in this file. so that we can look at it later. Okay, so let's get out. Now let's run. Okay, so the first value is showing me the temperature, second is showing me the light intensity, and then the third is showing me the probability. And you can see the Raspberry Pi keeps blinking blue light because it's operating at the usual temperature range and the usual light intensity range, so there's nothing for it to flag up. It's just working normally. However, if I now apply some heat just by holding it, the heat from my finger will transfer to the temperature sensor and it will continue to increase the temperature that it senses. If you look at the terminal, it's increasing slowly in terms of the temperature. Now, let me try to shine light from the top, but I better not be too close. So I'm going to continue holding the temperature sensor whilst lowering down the light. And if you continue to observe the readings, you will probably see the light and the temperature both are increasing in the value. I want this to be a gradual process, so I don't want to immediately trigger the anomaly detection. Okay, right. So let me turn this off first. So just now you saw the red LED flashed and the buzzer sound came on. This is because we have exceeded the normal boundary, and hence now the probability of it lying within the normal distribution is extremely low. Hence, it starts to detect a abnormal situation. What I want to do is show you guys how the gradual changes of the temperature and the heat has triggered the anomaly detection, and hence there's the red light glown and the buzzer shouted at us. Here I have basically get pushed out the numpy away and then went back to my local server and reading it back in, and now I can have my recorded variables back. Beautiful. Okay, I hope this graph is able to convince you how our model have worked beautifully. To make it more intuitive, what I'll do, I will plot only the last reading. Remember, the last reading that we have, that is what triggered the anomaly detection. So there you go. The red dot is our last reading. So during the rest of the data collection from the temperature and the light detection diode, it all lies within this contour plot, which means it lies within a reasonable range, but only when I have shown the light a bit too close, and then all of a sudden, the intensity of the light that sensor has detected suddenly increases dramatically. So this is certainly a data point that lies very far away from the normal distribution, and hence it triggered the anomaly detection and the red light glow and the buzzer buzzed. I hope you enjoyed this video, and hopefully this Raspberry Pi implementation to simulate how a machine components could suddenly overheat, and our model that is trained for detecting this anomaly has worked perfectly well in this situation. So I hope you enjoyed this video. Thank you very much, and I hope in the near future there will be more of this or of this video that will come out.